So good morning. I am Bryan Liles, and you will be hearing from me a lot today. And I guess the bonus for me emceeing is that I get to do a talk too. So if anyone asks you to MC and you really want to do a talk, it's a great way to not submit an RFP for a conference. All right, so this part should have been taken care of 5 minutes ago, so this is how the magic happens. All right, so today I want to talk about writing Go and thoughts on running Go services. But just a few minutes ago, a coworker of mine says, "What's your title?" And I said, "Oh, I don't remember, let me look." So I was thinking about what was in the talk, and I'm like, well, maybe it's actually something like that. So here's something that I speak at. Last year I spoke at 36 events on multiple continents all over the US. And every time you go somewhere, you always have to do the speaker check. What does the screen look like? This is a new one for me. This is going to be a challenge. So everyone who is speaking today, realize there are lines running through your talk. So you might have to adjust your environment. So use the rectangles to your advantage. Don't do this. Well, if you do this, realize this is going to happen. And maybe you could just do something like this. And now we can really get into my talk. So writing Go, thoughts on writing and running services. I am Bryan Liles. I go by Bryan L on Twitter and GitHub. And yeah. So let's talk about the basics. And this is a Go talk. Let's talk about why we like Go. Well, I came to Go because I actually came from Ruby, was my previous primary language before Go. And doing more than one thing at once in Ruby was meant that you really just launched a new process. And Go routines were pretty interesting to me. And here's some code. I will show code because I figure if I'm talking at a programming conference, at least a third of my slides should have something code related on here. It's not really important to read, but if you go right here, you see there's a Go func. Really what this is doing is it's running code in the background, and there was no burden on the developer. And that's really one of the signs of a good programming language. You can do what you need to do with the least amount of burden on you. In Ruby, I could have done something similar in Python and Perl and C and Scala. And actually, I have to think about how to do this in Haskell. I could do this in OCaml. But you see where I'm going. Go actually made this pretty simple. Also, what we came to Go is standard libraries. And I keep on going back to Ruby. Ruby has an interesting standard library. There was doing things in Ruby and their well-documented standard library. It's pretty nice. But Go has actually a very, very good standard library. And my canonical example is how many lines it takes for me to write a web server or a REST. This thing actually does nothing. It will answer for pretty much anything you send at it, and it'll just reply back. Hello, capital Golang. You don't do this because you're not setting any of the proper headers. You're not saying what your status code is, and this is quite not the right way to do it. But it was easy for me to show you that this is possible in only a few lines. And think about this: Go is a statically typed compiled language. It's not dynamic in any way, really. No easy way. So, but if you think about what I've done here, is I've actually made something usable in only a few amount of lines. And another thing about Go is the one binary. And actually, if you were going to ask me the reason of why I really like Go, I can compile it to one binary. It compiles quickly. For those of you who come from Scala land, there's no SVT. For those of you who come from Ruby land and you're trying to figure out, well, what Go do I need to put on there? Am I using RDM or am I using RVM? Notice they sound alike, but I did say two different things. Is it, if you're using Python and you're thinking about virtual env, you don't think about anything like that. You don't have to worry about your libraries. Once you compile it, it's ready to go. So I was always thinking, and I work at Capital One, and this is actually a surprise for me. I have done startups for, I did a little stint in the government. I don't know what I was thinking there, but But I've mostly worked for startups over the last 22-ish years that I've been calling myself a professional. And I always come into these programming projects and I always wonder, how do I start? And this talk is not about how do I write Go syntax. It's talking about how do I write Go and be productive and contribute to some greater goal. So what do I think about when I'm writing Go? And this is something that comes up all the time. Go has package imports, and people always say, well, I'm going to create this. I did this thing. I created this. When I was at a company I was at before called DigitalOcean, I created this thing. It had a package for everything. And then I found quickly that I got into my circular dependency. So guess what I did? I just put them all in one. Screw that. So I'm actually going to offer up some ideas here about package imports. So if I have this new app that will be coming out soon called WooWoo, I'm not going to tell you what it's going to do, but I just start from here. And because I know that if I'm going to create a binary, I'm probably going to create two binaries because I've seen this where people will create a binary for their service, but then they might also create a binary that runs their migration to the database or does something else. So we're going to get into this whole multiple binaries things. So you notice, actually, quick survey, and this will be helpful for all the rest of the speakers. Go experts. I hack Go for money at work, and I'm more than productive. I started hacking Go yesterday because Mark showed me how to do it. Go just sounds neat, and the conference wasn't that expensive, and it's Wednesday, or Tuesday. All right, I see where we are here. So, for those of you in the last two categories, just work with me. I'm sure this will be entertaining. So you have your package import, and basically with Go, you can only have, in a directory, you can only have one main package. So we talk about creating multiple, and this little way of doing it is, under my WooWoo, I create a command directory, and I create another WooWoo, and whenever I generate the binary, it'll actually, when I build this thing, it'll actually take the name of the last part of the directory and call it WooWoo. You now see why I call this WooWoo. So, starting from main. So here's actually, this is like the crux of my talk, and this is all I really wanted to talk about. Everything else is just whatever. But when you start writing a Go app, do not create a whole bunch of packages. Actually, start coding your app in main. And you're gonna say, that's crazy. No, really it's not. Create your app in main. Create your initial structures in main. Create your test in main. And what you're gonna find out in a while is that main becomes uncomfortable. You're gonna start getting your main file that's gonna be 400, 600, 1,000 lines long. You're gonna say, this is not right. And at that point is when you're gonna make the change and start creating your own packages. So, for those of you who can't hear, I created notes. So, what's in your first package? Really, probably your domain structure. So, everyone likes to do type whatever, struct. This is what's going to be in there. So most likely your domain objects. And I say domain objects, but they're not objects. They're actually domain structs. So and then after you're going to have your main, then what you're going to do is you're going to start taking your app and splitting it up and finding out what parts of the app work together. So an example I like to use is that my database access, and I like the repository pattern. I'm not going to go into it here. You can look it up on the internet. It's going to lead you to a site over at Microsoft. But I trust you. Trust me, it is a good site talking about repositories. So your app actually should know that it's dealing with a database, and the way that you can encapsulate that is by creating a repository that talks about all the access that you would have, and you can just work on those. It actually does help with testing. And then really what you're trying to do here is ultimately you're going to take everything out of your main except for your initial configuration and whatever you're doing for dependency injection, and you're going to use main to tie that in. And really, if you're thinking about it, your main's going to go, whenever you start an app, your main's going to go from big, and then it's going to go back small again. And I'm just trying to see, can everybody see me? All right. All right, I'm going to move over here too. I think I'm pretty good looking, so I want everyone to be able to enjoy this. And then also, I just want to talk about this for a second. When I'm talking about package layouts, are just words, but the best description I've ever seen of this is a blog post on Medium. I did not put the URL in. I actually, it's easier just to search for standard package layout, Ben Johnson in Google, and it's going to lead you to a Medium site, and he explains this way more in depth than I care to. So what other things that I see about when we write Go? Well, first of all, don't unit test what you don't own. And what do you own? What is what you own and what you don't own? It's very simple. If you didn't write it, don't unit test it. Make sure you're always encapsulating your dependencies. And here's a new one that I've seen circulating now in the Go world is, accept interfaces, return concrete types. A good example of this is if you have something that conforms to an interface, let's say you have a builder of some type, and you maybe have a lazy builder. Whenever it creates the lazy builder, make it return, maybe a pointer to a lazy builder. Don't actually return the builder. So for those of you all who've seen me talk, know that I cannot have a talk that does not talk about testing. I like to talk about testing just because I think I talk about it well, but I really think that as a programming community, some of us test well, but most of us do not test well enough. So this is something else I like about Go. And notice that I did not change my slides here, so the next three, I apologize. So running tests with Go test. You don't need anything fancy, you can actually just run Go test. But what I find a lot of people aren't doing is actually using the race detector built into Go. Who here does not know what the Go race detector does? All right, this is amazing, so I can teach something to you all today. So Go, whenever it is being compiled, what they actually do is they break it down into an abstract syntax tree. I'm not going to talk to you about how that works. But what they do is then they can actually apply math to it and determine if this access to this entity is actually going to mess up an array. So you started a Go routine and you can access a variable from more than one thread. Go can do that for you. So it doesn't take much longer to run the Go race detector, but it does not run as fast as Go test does. But just remember that you should be running this at some time in your integration process, or just even before you actually commit. Another thing I don't see people doing is running the coverage of their code. And some people think of this as a vanity metric, but I actually like to know that if I introduce code, is it tested or is it not tested, and seeing the percentages go up and down is actually pretty nice. And if you're using any of the modern environments, I know there's some Vim users here who are using the Vim Go thing, actually created by an old coworker of mine. I actually use Visual Studio Code because it's better. And it actually has great things for running code coverage in there, so you can actually see green and red, what is being covered by test, what is not. And generally, I'm not even talking about TDD anymore, but sometimes I just don't do it. But really, it's nice to be able to write some code, write a test file, and be empty, and run your coverage, and then actually be able to see how you convert the reds to green. Here's another controversial topic. So testing, I'm not going to talk about how to test, I'm going to talk about some things in testing. So Testify, anyone here use Testify? Testify. I worked at DigitalOcean for years, and one of the biggest controversies in that company with all those fine engineers was Testify versus not Testify. So I wrote some code here, and I'm really big on code that fits on a slide, so it's not very hard to read. Really, what all I have here is something that does magic, and we want to create magic, and really magic is if A and B equals 4, because it's magic, and I don't know why, because it is magic. But I wrote this code here, and I want to write a test. So I have a test. And in the first test create magic 1, what I'm doing is actually not using any dependencies, and I'm going through, and I'm doing this in a way that, this is kind of like what I would call the Google way. So if dot how expected equals my results and what I did expect, and dot equal to expected, then I can arrow f that magic equals this, and I expected that, and that's fine. But I'm a developer, and I'm actually kind of lazy, to tell you the truth. And why write all those lines when you can write 2 lines? You can do your create magic, like I'm down at the bottom now. You can write your create magic, and you can actually just do assert or require.error. I did require because require will actually kill it. It will kill the test at that point and not run anything below it. And I just do require no error, and then require equal. And for those of you who aren't really familiar with Go, but have some familiarity with any other programming language that's in this style, you can pretty much tell what that's going to do. Rant over. And also, Testify does something neat, is that it creates good error output. Because if you do, and I'm not saying that you shouldn't, but if you do not use any dependencies, you should actually go the extra step and create great error output. So you notice on the first one, the first test it died on line 12, and it just says expected magic. I would have to type something else to make that work. But on the second line, it actually gives me, this is what I did expect, and it's better for future Bryan. And then something else I want to talk about is mocks. And this will be really quick, because mocks are neat. Since I'm super into testing, and I want to be able to test how things work, and I really don't want to code around my testing. So really, I'm encouraging people to at least look at mocks. And what mocks do is you can substitute them for something real and tell them how to behave. And in this case here, I have a builder, and then I have a concrete instantiation of this builder called lazy builder. Something I want to point out, and something that I don't see enough. This is my pro tip for this part of the talk. This line right here. What this line does is this var underscore builder equals this lazy builder nil. Does anyone know what it does? Besides Mark? Yes.
Proves that builder implements interface. Lazy builder implements builder.
Right. What he said here is that it proves that this implements this. Why would I want that here? Because if I'm using any modern editor that will actually run through the code, this actual line, this will actually make this line turn red. So I'll know that if I have 4 or 5 ends in here that I actually have not implemented. So it's just a little trick that I do. It allows you to see before you compile it yourself that your code is actually implementing the interface. So I'm actually showing this mock. So Testify has something called mocks in it, and there's a tool called Mockery. So Mockery, M-O-C-K-E-R-Y, and it'll generate these mocks for you, and I'll show that next slide. But what I'm doing here is it allows you to create dying here. No, I actually build one of these mocks, these builders here. And then I'm telling it that whenever you get the build, just return nil. And then there's no error. And then down here is the negative side. I can actually also make it do an error. And if build took any type of arguments, you can actually put the concrete ones in here, or you can actually, Testify mocks allows you to say that if you get a type of this. So it still allows you to test your code. You don't have to change your actual code to know that it's being tested. That's a big problem that I see, is that we should write code that should be tested, but we shouldn't be changing our code to allow for testing. And this is what Mockery generates for you. You can actually write this yourself. It's actually pretty simple code here. It just actually goes through and it calls all the right things for you, and it makes all the checks. So running. Well, here. So let me actually go to the next slide. Yes. So I actually wrote this. I'm full of examples this morning. So now I have this thing called running code. And really what this thing does is it accepts strings, and if it encounters a number, it knows that it's a number. And pretty simple piece of code here. Here is the output. But let me talk about how we would test this. And this is something that came up a few versions of Go before, is that old school, even the Go developers will tell you that we want test cases. We want to be able to not just test one input, we want to be able to test multiple inputs. And what they prescribed is that you would basically create an anonymous struct, and in that you would find the pieces of the anonymous struct, and then you would instantiate that anonymous struct all in one go. So all this lines here creates these cases. And then you would iterate through your cases, and then you would run all your tests. And what happened, because we had that, is that a lot of people started thinking, well, in Ruby, if you were using RSpec or something like that, this is super simple. And this is what I like about the Go team. They actually came up with a great way to bring us most of the way there without giving you that full level of dynamics. dynamicism that would, I might have made that word up, but you know what it means, so I coined it, that's my word. So it's giving you that level without taking you all the way down to the way of being fully dynamic. So I'm running this code here, and you notice that it has my output, kind of neat. But well, let me show you something here at the bottom. So you notice this line right here where I'm doing this t run. So really what I'm doing is I'm actually creating what you would call a subtest. Or I don't actually know the name of them, but I'm going to call it a subtest. But what it allows me to do is when I run this thing, so this is basically I'm saying t.run, taking that test and doing a t.run, and I'm actually creating a new name for it, and then I'm having my own little testing method here. So when I do that, what it allows me to do is get great test output. And that's really what this is all about, is I want to be able to see what's tested rather than just seeing that I have a billion methods. And what this also allows you to do is keep all your tests for something in the same function. So I think this is actually an awful lot. And I want to show you this real quick. If you don't know about pique, I don't use it often, but whenever I just really want to have an automatic test runner in the background, because we should always be testing, I pull up pique, and what it does is it just checks when your file system changes, and it just runs your test for you. And the neat thing about this is that it also does the coverage for you as well, and it gives you green check marks when everything is good. pique also has their own testing library inside of there. I don't use it very often, but it is available. So another thing that we forget about is you've seen all the memes where on the internet where there'll be something wrong, there'll be a picture, and maybe there'll be a faucet handle, but the sink is only this big. And it's like, 2-unit test, no integration test. We need to think about our integration test. And really, and I'm telling people this is actually, it's still a green pasture for Go. There's not a great canonical example of how to do integration testing, but we should really be thinking about integration testing. We test our units, but then we need to integrate our units and determine how they work together. So the next section is Go in production and vendoring. I actually don't have a slide for this. I just want to talk about vendoring in general, and I'm going to give you my opinion on vendoring. So some people will say that if you use it, so you can use a vendor directory, you can put your things in there. Or you can use a tool like GoVendor or GoDep or GBT or the new one that the Go team is creating, Dep, and you can use that. But what some people will say is that don't check your dependencies in because they use the old adage of we should not be checking our generated files in. I'm going to actually say that's something to think about and probably not do. And the reason why is something that the Go team did to us, and they didn't do it on purpose, it's just how Google works. But really, Go doesn't have great versioning of packages. So when you pull down a dependency, you get what it was. And if someone else goes and they pull it down, what do they get? Well, maybe they get it because you're using GoVendor and it actually has the SHA-1 in there. But what if that SHA-1 goes away? Or, because sometimes I force push delete things because you know what? It's my repo, I'll do it. Then it will go away. So I'm just telling everyone, just bring that stuff in, pull it down. Yeah, it does make your repo a little bit bigger, but at the end of the day, you will have everything you need to actually do your builds. And it also helps for me on airplanes, because I find that I write code in airplanes, and I'm able to do all the things and not have to worry about where my packages are coming from. And then I can also have multiple versions. One of my favorite topics, logs are for people. So I'm not saying to use Log-Rust. It's one of my favorites. There are faster ones out there. There are better written ones out there. I like Log-Rust because I like their API and I like how it looks on the console. But really what I'm trying to say here is that whenever we're logging, logs are for people. Remember that. Even if they go off to Elasticsearch or CloudWatch Logs or Graylog, or hopefully they're going somewhere that's not on your machine. That's actually the other pro tip. Your log should go somewhere else, not on your machine. But when you're writing logs, the world has actually been ruined by Apache. Apache created this thing called a common log format, and it's not very common. You can't even really parse it. You can't parse it with a computer. Have you seen the regex that actually parse that? That's not common. So what I'm actually telling people to do is use logs that have a little bit of extra stuff on them, a little bit of metadata. And this is how Log-Rust looks in the command line. Notice that it has it actually split this out. So It has the level, it has how much time elapsed, it has the message, and then it has the metadata on the right. And then also, so that's only for humans, but for computers, we can actually generate JSON-based logs, and it's all in there, and that can be put right into Elasticsearch, and we can build great things on that. Just remember that friends don't let friends log like Apache. And that's just what I said. And then also remember that if you're running an app in production, that metrics aren't logs. So logs are what your app says it's doing. Metrics are how we measure it. And I'm not going to talk much about Prometheus or InfluxDB or OpenTSDB or CloudWatch metrics or whatever else, or Stackdriver or whatever else you happen to be choosing for your logs. I have metrics. I actually don't care. StatsD, Graphite, whatever. I don't care. What I'm really saying is that your application should have some way to provide metrics. And there's two ways. One is you can actually use Prometheus, and this is what's neat about Prometheus. Prometheus actually creates an endpoint, and I know it's at the top, it says /metrics, and what Prometheus does is it creates an endpoint, and it exposes all your metrics as a text file, which means they can be pulled from not one source, but actually n number of sources, so you can actually scale out your logging or your metrics collection independently of your application. But that's only one way, and I'm not here to talk about push versus pull. And this is just code to show how easy, actually, and this is actually the other way. But how I was saying earlier that the Go standard library pretty much has a lot of things in there. You'll notice at the top of this line, at the top of the imports, I imported, I don't know how to say it, so we're just going to call it expvar. And what it does, it brings that into your package, and notice I use the underscore, so that means it brings it in without a package. And because it does that, it'll actually attach to your default HTTP handler, and it gives you some neat stuff. And that neat stuff looks like this. Not neat for us, neat for computers. Computers like JSON better than we do, but using this kind of things, we'll be able to tell how many Go routines, how much memory we're using. So for those of us who like to leak Go routines because we're using context, and we don't actually, and whenever we do with cancel, and we don't actually call that cancel method at the end, you're leaking. And I'll tell you what, this will show you all those Go routines you leaked. And then also, here's something new, is talking about events and observability. So I talked about logging, I talked about metrics. This observability thing is neat. Is a newer way of thinking about this. So whenever you do something in your app, whether, I don't care what your app does, you should be able to create some kind of log about it and some kind of metadata. And what we can do with those things in the future is we can actually use those to put together long lines of things that have happened. So if something broke, we can actually figure out how we got there. There's a company who's kind of trying to pioneer this way called honeycomb.io, and they're really it's really new space, but they're talking about instead of just monitoring, we should be able to create events, and then we should be looking at the observability of our applications. And then, very important thing. So we created our app. We somehow moved our app to production. I'm here to talk about that. We have to realize that exceptions happen. We have errors. We have panics. Hopefully you don't have panics. Hopefully you're recovering or not issuing panics. But sometimes it happens. So what do? And I'm going to give you a solution. It's an easy solution. It's an open source solution. Is using something called Sentry. And this code right here, and I'm just showing you, the reason I'm showing you it this way is because this is how easy it is to fit on a slide. There's not much work. You set up a Sentry server, that's more work. But then after you get it, you can just point your app at Sentry, and whenever errors come, this is what happens. You get a nice little GUI here that says, hey, you have an error. And I don't know if I have a slide for, I actually do have a slide for this, where you can actually drill down to the source for your error, and this will capture it for you. So for those of you who are leaking Go routines out of your context, and your app suddenly just starts breaking, and you don't know why, you can come here and see it. And Sentry is open source and neat, and it's not very hard to install. So now let's talk about running Go. Arguments or environment variables. Who prefers arguments, like flags? Who prefers environment variables? Who doesn't care? I'm in that camp. Not really don't care. But I will tell you that if you are moving toward, everyone's thinking more about containers, passing flags in containers it's harder than doing environment variables for containers. Actually specifying the environment of what should happen is actually easier, unless you have 50 to 100 environment variables, but then you need to think about maybe we need to be passing in some kind of config file. But I wanted to show a way for people who wanted to step beyond flags and using flag.parse. There's reading your environment variables out of or your configuration settings out of your environment variables. And I wanted to talk about something that Kelsey Hightower, people don't realize this guy. He writes a lot of code, he talks about a lot of things, but every once in a while, he comes up with something useful. And you can tweet that Bryan Liles said that to him, and he just laughed, and he'll text me later, and we'll have a laugh about it. But I still said it on tape, so it's pretty funny. But this is actually a great piece of code right here. And what it does is it allows you to define your specifications in a struct. And you can annotate those, so you'll see in my next slide that I'm actually saying this int, the default will be 9. You can set that it's required. So I'm saying that this bash string has to be required, and if it doesn't, and whenever I run this and it's not there, guess what will happen? The first time it'll just die, it'll send back an error saying that this is not good enough. And then the second time I run it, what I'm doing here is I'm actually changing it. I'm changing some of the environment variables, and the third is I'm actually overriding the default. Notice here that I'm actually using the best shell in the entire world. It's fish. If you want to talk about this during a break later, I will tell you all the reasons why fish is more amazing than any other shell, including Z shell or Z shell. It's great. Except on servers, use bash. Don't use anything else but bash on servers. And we're coming towards the end. I don't have any code for this, but I do want to talk about same code, multiple environments. If you have conditionals in your code that say, if I'm in production, you need to figure out how to delete those lines. Because those right there, those are what I like to call landmines. And they're not landmines for you generally, it's for that new person that starts and they're not really good at Go, and now you've wondered why you deleted your production database. This is why. Don't even let people get to that point. So figure out how you can run the same code multiple environments, use flags, whether they are flags from the environment or flags from the command line or flags from configuration. Please do that. And then also think about your builds. Our builds are reproducible pretty much in every way. When I build version whatever of this, due to some nuances, maybe the exact binary won't be the same. But we really should think about giving this SHA-1, I should be able to build something that works exactly the same, has all the same dependencies in it. And wow, I'm about done here. And I did go a little bit long, but there's good reason for that. It isn't all about syntax, just remember that. And also remember logs, metrics, and errors. Please remember that. And then finally, Go is simple. Neat thing that I want to say is that remember, Ruby was MinSwan. Maths is nice, so Ruby is nice. So we are nice. And it's really simple in Go. Go is just simple. If your solution is complex, it's wrong. So think about a much simpler thing to do. And that's it for me. I'm Bryan Liles, and I'll give you my plug. I work here at Capital One. Fun thing is I'm not a banker. This is the biggest company I've worked in by far. I recently was at a startup, and I still think in that mindset. If you are actually just thinking of apprehension of working at a big company, there are great things going on in this company. I actually travel an hour and 45 minutes every day to get here, and I love what I'm doing. I am doing things that, we're doing all those things in startups we would do if we had money, but we didn't have any money. And working in a bank, you find that money is actually, that's something we don't think about or talk about. It's like, oh, you know what? All this O2 in the air is great today. I'm really breathing fine. It's one of those things, but it's great working here, and also that we are trying to get back to the community by sponsoring this and other conferences. So please come talk to me, and thank you. And next up, before you all say anything, will be Kaylin, and she's going to come up right now. And I'm going to answer any questions while she gets set up, if you have any. And only questions, not comments. Any questions? Yes, sir.
So what was actually the controversy with testify and
So I'll tell you, so the question is, what was the controversy about Testify and Standard Library? So it actually wasn't specifically Testify. It was because there is a very large, there's a very loud contingent of Gophers. who say that standard libs are the best. They're the same people that say that we don't need frameworks, because we can do everything with HTTP. But then they don't create front-end websites, so they don't see how hard it is, and they don't have to use templates, so they don't know how silly that is. I'm not saying that it's silly in itself, it's just silly because it's hard work. So that was the argument, and that was the argument that we should remain pure. And I don't think pure gets us anywhere. So I'm here to help the business make money. We can have our religious comments later, and I'm not going to be there because I don't really want to talk about it. So next up, so thank you all, first of all. Hopefully I didn't bore you all.